Welcome to this presentation. This presentation will be on the chemistry behind the pyrotechnics that are used in movies and TV shows to create practical flame effects. I'll be explaining how they produce these different coloured flames and how they are created. First of all, let's go over how the special effects department creates different coloured flames. First of all, they would take a log of wood. Depending on which colour flame they want, they will select a certain compound to produce this flame, as each compound has its own unique coloured flame. There are a few steps that are needed to be followed to prepare these logs. The first step is to soak the logs in an alcohol solution for a few hours. Second step, transfer these logs to an aqueous solution of the compound of your choosing. Third step, take the logs out and leave them to dry for 24 hours. Fourth step, cover them in sawdust and pine cones. This allows for them to catch fire easier, and this allows for better results. The fifth step is when the logs are all ready. So all that is left to do now is to step back and set them alight. When one of these compounds is set alight, the thermal energy rises. This causes the electron state within the atom to move to a higher energy state. Electrons cannot remain in these higher energy states for too long, and therefore will emit energy in the form of a photon of light. When this photon is released, the electron will return to a more stable ground state. This is much lower in energy, so therefore is more stable. The photon that has been released will appear in the visible section of the electromagnetic spectrum. Depending on how much energy is released, we will see different colors in the visible portion of the electromagnetic spectrum. If it is lower in energy, we will see it towards the red, and if it's higher in energy, it will be more purple. To produce a red flame, lithium chloride is used. Lithium chloride is the main species that causes this red flame to appear. Lithium will have a melting point of 605 to 614 degrees and a boiling point of 1382 degrees. It produces a red light which is between 620 to 750 nanometers. On the electromagnetic spectrum, red light can be seen in the visible section. Red light has the lowest amount of energy compared with all other visible light. An orange flame is produced by burning of calcium chloride. Calcium is the main species that causes this orange flame. Calcium chloride will have a melting point of 772 degrees and a boiling point of 1935 degrees. Orange light has a wavelength of between 590 to 620 nanometers. This is towards the lower end of the visible spectrum, but is still a higher wavelength than red light. To produce a yellow flame, sodium chloride is used. Sodium is again the main species that causes this yellow flame. Sodium chloride will have a melting point of 801 degrees and a boiling point of 1413 degrees. Yellow light has a wavelength between 570 to 590 nanometers. This is towards the middle part of the visible spectrum, so will have a higher wavelength than red and orange light. Copper sulfate is used to produce a green flame. Copper sulfate will have a melting point of 110 degrees, but it seems to decompose before it starts to boil. This happens around the 600 degree mark. Green light will produce a wavelength between 495 nanometers to 570 nanometers. This is pretty much the middle part of the visible spectrum. A good example of this effect being used in practice is in the TV show A Game of Thrones. In Season 2 there is a scene called the Battle of Blackwater, where a green fire is used to burn the invading enemy ships. The special effects team probably used boric acid or copper sulfate to create this green flame. A blue light is produced by burning copper chloride. Copper chloride is the main species that will cause this blue flame. Copper chloride has a melting point of 498 degrees and a boiling point of 993 degrees. For a blue flame, it will have a wavelength of 450 to 495 nanometers. This is towards the higher end of the visible spectrum. The violet flame is caused by two compounds, potassium sulfate and potassium nitrate. Potassium sulfate has a melting point of 1069 degrees and a boiling point of 1689 degrees. Potassium nitrate has a melting point of 334 degrees and a boiling point of 400. When these two molecules are set alight, the result is a purple flame, which gives rise to a wavelength of 380 to 450 nanometers, which is at the very top of the visible spectrum with the smallest wavelength. Thank you for watching. I hope you have learned something about what goes into making different coloured flame effects for movies and TV shows.